Welcome back to Computer Science Tutoring. I'm Oleg Silkin, and today we're going to be talking about integrity constraints. Integrity constraints are rules that we set on our database that our database sort of has to hold. And there are a lot of different types of integrity constraints. For instance, there are domain constraints, which specify that we have to have like a certain type of data. So for instance, a student's grade might be a letter or it might be an integer. So that would be an example of a domain constraint. Another type could be like if you had the credit hours for a course and you specified that the credit hours needed to be an integer. Now what would happen if you inputted a letter or say an invalid character is that would actually trigger a domain integrity constraint, which would prohibit that entry from going through because you're trying to put the letter A into the credit hours, and credit hours only takes numbers. So that's one type of integrity constraint. Now, for this example, we're going to be doing 5 integrity constraints on a student database. So right off the bat, the easiest type of integrity constraint to uphold is going to be a primary key. So a primary key. And for this, we can go to student number. So we can say that student number in the student table, so that's going to be right here. Student number is a primary key, is a P key, and therefore unique. And this would be a very valid, integrity constraint, because if you try to put in a new student record and it has so you wanted to have like a new student. So let's say you wanted to put in Oleg as a student. And if my student number is 17, the database would freak out because it sees this student whose number is already 17. And that wouldn't make any sense because if you wanted to uniquely identify them by the student number, you can't have two records be in the database and also unique if they're the same thing. That's like when you have a function in math and you wanted to have like a vertical line test. You would say that every point on a line needs to match to exactly one vertical line. So if you drew a vertical line, it would only intersect the function once. And obviously that makes sense for a function because if you have a function like this would be a good function, but then if you have something like this wouldn't make much sense because you have this x value over here, which maps to two different points on the graph. And so if you did, so let's say this is like at 8. So if you did f of 8, now this would be undefined because the function only knows to get you the value at 8. But if there's two values, it doesn't know which one to give you. It doesn't know to give you the negative one or to give you the positive one. So in the same sense, you can't have two records with the same ID. So that would be one type of integrity constraint. Now, another type of integrity constraint would be to specify that the student's grades in the grade report must be either between an A, they can only be of the following characters. So you can only have the grades between A, B, C, D, E. No, you can't have D or E. You can only have A, B, C, D, or F. So grade in a grade report must be one of the following characters. Characters A, B, C, D, or F if you fail the class, right? It wouldn't make any sense if you had an E in here because we don't have any grades for E, and it wouldn't make any sense to have a Z in there because that just doesn't make much sense. So that would be another type of integrity constraint that we could do. We could also say that we can have a composite key in the grade report. So this would mean that grade report must have a unique combination of student number and section ID. So grade report, and that would mean that you can have multiple student numbers. So you can have like 17, and you can 17 and 112, and you can have 17 and 119, because together they are two different values. So at least one of these two is different. So you have 17 and 1119. However, you can't put in a new record that also is 17 and 112 and just have it be a different grade, because then you'd have two different grades for the same student and the same course section. So we would say that student number, or we would call that a composite key, and we would say grade report has a composite key of student number and section ID. Section ID. These two must be unique. The combination of them must be unique. Then we can think of another domain. We can think of another integrity constraint. So if we look at the course sections, we have a semester table, and we see that this is going to be a seasonal value. So it's going to be either fall or spring. Now, you can have summer semesters and you can have winter semesters. So we can say that semester must be either winter, spring, summer, or fall. And that would be another constraint. Now lastly, we can say that you can't have, we can say that you can never, that student must always have a name, because student number is going, if student number is the primary key for the student table, then then you can have multiple students with the same name, but they would be different students technically. However, those students would need to have a name, otherwise it doesn't really make much sense to have that student number be a record. So student must have a name, have a name / cannot be null. Be null. And that would be 5 valid integrity constraints that you could impose on this student database. So that's the end of this video. Thank you for watching, and I'll see you next time.